Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 2 class. Today we're going to continue with polynomial operations. And in particular, today we're going to learn how to multiply polynomials. In order to multiply polynomials, we must be able to incorporate and use our our product operations that we learned yesterday, and that sounded really weird. I'm sorry. I'm a little bit dazed. X to the n times x to the m equals x to the m plus m. So our product rules for exponents. That's what I meant to say. Sorry there. Okay, when you multiply the same base, remember, you keep the base and you add the exponents, okay? You also have to remember the distributive property. Please remember that the distributive property simply states that when I have something on the outside of a polynomial, I'm going to multiply that value to everything inside of the polynomial. Doesn't matter if what's inside of the polynomial is being added or subtracted. The outside value will be multiplied to the inside value of that polynomial. If you can remember the distributive property and the product rule of exponents, you've got this lesson down. That's it. I can pretty much, actually, to be honest with you, close up this lesson right now and give you the homework. Because it's that easy if you really, truly learned what I taught yesterday. But of course, I'm not going to do that to you, but that's how easy it is, gentlemen. And everyone out there in cyberspace watching. So let's go ahead and practice. I've got negative 2x squared times 5x cubed minus 4x squared plus 3x minus 4. I want to simplify this, okay? This is a distributive property. So I'm going to go ahead and literally distribute. So negative 2x squared times 5x cubed is negative. There it is, 10x to the 5th power. That's it. Then distribute. So it's just, there we go, 8x to the 4th, beautiful, minus, bless you, 6x to the 3rd, and then plus 8x squared. If I can, I add any like terms, which in this particular case I cannot. So literally, I am done. That's it. I am done. No, it would not be cubed, sir, because x squared times just 4 would just be x squared. But thank you for caring, sir. And next, 3y times 2y squared plus 5y minus 3. We're going to go ahead and distribute. So that means I'm going to multiply 3y to everything inside of this polynomial. And my answer will be 6y cubed plus 15y squared minus 9y. Done. That's it. It's over. Give me 1 second, please. Okay. So, next. Same thing here, guys. We're multiplying a monomial to a polynomial. So we're going to distribute this to every single term inside of the polynomial. So I've got negative 10x to the 9th plus 15x to the 8th minus 5x to the 7th plus 5, no, come on, learn how to multiply, 20x to the 5th, y. Threw that in there just so you can remember you cannot add the exponents of variables unless it is the same exact base. Does that make sense, gentlemen? And that's not an 18. That came out a little sloppy. I'm sorry. That is an 8. That was sloppy. Sorry. Does that make sense, gentlemen? Pretty simple, no? All right. So that's multiplying monomials times polynomials. Now, second thing we're going to learn today is multiplying polynomials times polynomials. Multiplying polynomials is easy if you remember FOIL. FOIL stands for first, outer, inner, last. Let's see how this works. Okay. First we do the outer number, then we do the inner number, okay? What I mean by that, I gotta just show you with it literally by doing it. I take this outside number first, and I multiply to everything inside of the second polynomial. So x times x is x squared. X times 8 is 8x. Good man. Thank you, Papa. Next, I'm going to take this inside value, this is the inner value, and I'm going to multiply it to everything the inside of the second polynomial. So negative 5 times x is negative 5x, and negative 5 times 8 is negative 40. And now you literally add like terms. So this would equal x squared plus 3x minus 40. If you can see, guys, everything is building here. I wrote it in standard form, which is something we learned already before. I added like terms, which is something we learned already before. I multiplied polynomials, which is something new, but I multiplied polynomials by multiplying monomials, which is something we already learned before. It's building, building, building. Now, just for giggles, what would the degree of this polynomial be? I know it's a, okay, but what do we call it when the degree is 2? It's quadratic. Thank you. Very good. Very good. What's the shape of this function going to be? What is this graph? What's the shape of this graph? It's a parabola. It's a U-shaped graph. Very good. Okay, next. I've got 6x minus 5y times 4x plus 3y. So we're literally just going to FOIL it out, guys. So let's do it. 6x times 4x is 24x squared. Thank you, my brother. 6x times 3y is 18xy. That's exactly correct. Negative 5y times 4x is, that's right, negative 20xy. Very good, my brother. And negative 5y times 3y is negative 15y squared. Very good. Now I must always remember to add like terms. So I've got 24x squared plus, no, minus. Thank you. Good catch there, my man. 2xy minus 15y squared. That 15 did not come out very nice. So let's make a nicer 15. And there it is. You are done. It's that simple. Yes, sir. You always write these in standard form. From now on, whenever you're working with polynomials, you always write the answers in standard form. In this particular case, you can't put it in any order technically because they all have a degree of 2. However, when you have something like this where you have an x squared, an xy, and a y squared, this is typically the way you want to do it. Get the x squared alone on the left. The middle term would be the xy and the y squared on the right. And the reason why I want you to get trained in doing that is because the next step after this is factoring. And we're going to reverse everything. Okay? Thank you for asking, son. Okay, next, C. 4x squared times 2x is negative 8x cubed. 4x squared times 5y is exactly 20x squared y. 3y squared times negative 2x is negative 6y squared x. And 3y squared times 5y is 15y cubed. In this particular case, though, guys, I do not have any like terms. Now, you may say, Moro, what about these two guys? No, that's an x squared y, and that's a y squared x. So those are not like terms, gentlemen. Be cognizant of that. Be wary of that. Be careful. Last but not least, 2x times 3x, 6x squared. Very good, gentlemen. 2x times 5, 10x. Excellent, gentlemen. Negative 1 times 3x, it's negative 3x. Negative 1 times 5, it's negative 5. 6x squared plus 7x minus 5 after I add like terms, and ding dong, the witch is gone. Does that make sense, gentlemen? Any questions before we move on? Because I do have some more things to teach you about this. There's some special cases that I want to review. But I want to make sure that you got this down pat before we move on. Any questions? Alrighty. Thank you very much, gentlemen. Okay, now, multiplying any polynomial times another polynomial is just as easy. It is very similar to FOIL in the sense that each term of the first polynomial must be multiplied to every term of the second polynomial. So I want to practice finding the product of each of these. Now, there's nothing to fear here except it's a little bit longer, it's a little bit more tedious, there's going to be more like terms to recognize and add together, there's going to be a greater potential for error. So that means that if we got to practice a little bit more, we got to be a little bit more careful. We just got to pay attention a little bit more. That's all this means. So let me show you how to do it. I got x plus 3 times x squared plus 2x minus 5. So just like before, guys, I'm going to take this first term, and I'm going to literally multiply it to every single term inside of the polynomial. I don't care if there's 2 terms, 3 terms, or 17 terms inside that second polynomial. I'm going to take that first term and multiply it to everything. So I'm going to get x, good, plus 2x squared, good, minus 5x, awesome. Then I'm going to take my second term here, that 3, and I'm going to multiply it to everything inside of the trinomial again. So 3 times x squared is 3x squared, awesome. 3 times 2x is 6x, awesome. And 3 times negative 5 is negative 15, great job. Now we got to add like terms. Please be careful here, guys. Whenever I add like terms in long polynomials like this, me, personally, I like to sometimes label it. Sometimes labeling them helps me, personally, recognize. So x cubed is by itself. There's no other x cubes. So I've got x cubed alone. And as you can see, I canceled it out. That way I know I don't have to mess with it anymore. Now I'm going to underline, because that's what I want to do, the x squareds. You could underline it, put a circle around it, however you feel like doing it. You could do nothing if you want to. But just be careful. Keep track of it. I would suggest if you don't want to label it, at least, at the very least, scratch them out once you're done with it so you don't repeat it. Okay, so it becomes easier to see what you've already worked with and what you haven't worked with or what you have left to work with. So I got 2x squared plus 3x squared is 5x. Negative 5x plus 6x is just positive x. And then I've got a negative 15 by itself. And that's it. I am done. Does that make sense, gentlemen? Promise? Okay. All right. Now, this guy is going to be a little bit longer. In fact, I'm going to bring this guy up because it's going to be a little bit longer. Okay. So I've got 2x squared times x squared, which is 2x to the 4th. 2x squared times negative 4x, which is negative 8x cubed. 2x squared times 3, which is 6x squared. Very good. Negative 3x times x squared is negative 3x cubed. Negative 3x times negative 4 is 12x squared. Good job. Good job over there. Good job. Let me move this a little. Oh, wait. Hold on. Let me just move this a little bit over. Okay. Negative 3x times 3 is negative 9x. And then last but not least, 4 times x squared is 4x squared. 4 times negative 4x. Wait, we did something wrong. It's 4x cubed, guys. That was my bad. No, it's not. No, it's not. We were right. I was wrong. It is 4x squared. 4 times negative 4x is negative 16x. And 4 times 3 is positive 12. Okay? So we've got a very long list here. Okay, 2x to the fourth is by itself, so that's it. I'm done with that one. It's just 2x to the fourth. Now, x cubes. I got a negative 8x cubed and a negative 3x cubed, so that's negative 11x cubed. Goodbye. I've got a 6x squared and a positive 12x squared and a 4x squared. So I've got 6 plus 12 is 18 plus 4 is 22 x squareds. It's messy. So goodbye to the x squareds. Then I've got a negative 9x and a negative 16x. So that's negative 25x. And then I've got my plus 12 at the end. And that very long polynomial is my answer. And by the way, who would be able to read this properly? How would you read that polynomial by degree and term number properly? Sir? Quartic is correct? Nice! My man! Good job. Quartic 5-term polynomial. Very well done, my brother. Very, very proud of you, son. Very proud of you. Okay, next. 5x times 2x cubed is 10x to the fourth. Excellent. All right, tell me. Go. Tell me. Yes, 15x cubed. Go. Yes, negative 20x squared. Go. Yes, 5x. Go. Negative 8x cubed. Great. Go. Negative 12x squared. Go. Negative 16x. X positive. Good. Thank you. Go. Phenomenal, guys. Excellent. Now, let's clean it up. Do I have any other x to the fourths? No. So that's 10x to the fourth. Have a good day. Okay, I've got 15x cubed and negative 8x cubed. So that's 7x cubed. Awesome. You guys are on fire. I'm very proud of you. Negative 20x squared and a negative 12x squared. You nailed it. Negative 32x squared. Beautiful. Well done. I got a positive 5x and a 16x, so that's 21x. Phenomenal. And then minus 4. And that is my answer. Does that make sense, gentlemen? Okay. I'm going to bring this guy over here. We're good? Can I scroll up? You got this? Promise? Yes? Okay. All right, now. Okay. I want to show you what most people will do. Most people, wow, you started doing already what most people would do. Most people are going to go, this is x cubed plus 3 cubed. Yay! And that is wrong. Please do not do, no, it's not 27 either. Please do not do that. I did this on purpose. So everyone in the world, whoever sees this video, can see that that is wrong. That is wrong. No, please don't try to use logic. It's wrong. No, it's wrong. It's wrong. It's wrong, guys. Please don't try to legitimize this. This is wrong. This is why I put an X to it, guys. It's wrong. Does anyone think they know how to set this up? Okay. Yes, sir. Tell me what you think, my brother. Aha! Very proud of you, my man. Excellent. What this means, guys, is you got to think about what exponents mean way back to the beginning of the year. Remember that it's a base raised to a power. That means that the power is telling you, hey, reader, multiply this base this many times by itself. So this is x plus 3 cubed. So what this means is it's x plus 3 times x plus 3 times x plus 3. Please remember that, guys. Please. I've been teaching for a long time, and I don't know why, but people always want to say, oh, this is x cubed plus 27. No, it is not. That is wrong. Please, it's wrong. X plus 3 cubed is x plus 3 times x plus 3 times x plus 3. Now, how does this work? I want you to always remember to first do these two first, please. Okay? So this is x times x, which is x squared. X times 3, which is 3x. 3 times x, which is 3x. 3 times 3, which is 9. So this is x squared plus 6x plus 9. Now drop this down times your x plus 3. Now x squared times x is x cubed. X squared times 3 is 3x squared. Thank you, my brother. 6x times x is 6x squared. 6x times 3 is 18x. Then 9 times x is 9x. And 9 times 3 is 27. So now combine like terms. X cubed plus 9x squared plus 27x plus 27. And that is my answer, my brothers. Yes, sir. Once you went ahead and multiplied these two, my man, where I got this trinomial right here, then I had to multiply this binomial to that. I'm sorry, my man. No, I went x squared times x, which is x cubed. X squared times 3, which is 3x squared. Then 6x times x, which is 6x squared. 6x times 3, which is 18x. Then 9 times x, which is 9x. And then 9 times 3, which is 27. Thank you for your honesty, son. Appreciate that. Takes guts to be honest. Thank you. Any questions on that? Yes, though, maybe kind of, sort of? Promise? Okay. A few more slides, guys. We're not done. It's a long lesson. Okay, now. Special cases, guys. Special cases is a double-edged sword, okay? My classes and I always have a little bit of a situation here. Some people don't want to memorize the special case because, technically speaking, you know, I never lie to you. You don't have to memorize the special case. You don't have to. But oh my goodness, does it save time? And oh my goodness, when we start factoring, knowing these special cases is going to make you so much more efficient at factoring. It's going to make you so much better. It's going to be so much easier for you. You're going to be so thankful that you learned it. So I'm going to teach it, and then it's going to be up to you to determine whether or not you want to learn it. When you have a perfect square binomial or trinomial here, okay? You have a perfect square. When you have x plus y squared, we just learned that means it's x plus y times x plus y. You could do this the long way, guys. X times x is x squared. X times y is xy. Y times x is xy. Y times y is y squared, which is x squared plus 2xy plus y squared. You could do that. Or you could learn the pattern. And the pattern is square the first term plus twice the product of the first term and the second term plus square of the last term. For example, x plus 5 squared. What's the first term, which is x? What's that squared? X squared. What's 2 times x times 5? 10x. What's 5 squared, which is my second term? You're done. You tell me which is easier. Learning it or doing it the long way and being a hardhead about it? Learning it. So it's the first term squared plus 2 times the first term times the second term plus the second term squared. If there's a minus in between the x and the y, just like you see down below, it is exactly the same thing, except instead of there being a plus, there is a minus. Okay? So the rules are exactly 100% the same. You have my word of honor. For example, right here, I got x minus 6 squared. My first term is x. Square it. That'd be x squared. But there's a minus here. So you go minus 2 times the first term times the second term. So that's 12x. Plus the second term, which is 6 squared. Tell me that isn't pretty, boss. Talk to me, guys. This silence scares me. Silence always tells me you guys don't know what I'm doing. Talk to me. Yes, sir. Okay, luckily that's why I have a video. Okay? Okay, what don't you understand? First term is x. I squared it. Then 2 times the first term, which is x, times the second term, which is 6, is 12x. Plus the second term, which is 6, squared. Thank you for your honesty. What don't you understand? It's written down right there in front of you in different colors. You take the first term and you square it. Then, in this case, because there's a minus here, my brothers, it's minus twice the product of the first term and the second term, plus the square of the last term. So again, it's the square of the first term, plus or minus, depending on what they give you, 2 times the first term times the second term, plus the square of the last term. So if I gave you x plus 3 squared, first term squared, what would that be? First term squared, guys. X squared. There's a plus here, so plus 2 times the first term times the second term, 6x. Plus the second term squared. Tell me, talk to me. I appreciate the honesty. Talk to me, Papa. Now all of a sudden it's just, oh, okay, I got it? Are you sure? Or are you just telling me something to placate me, to make me happy? What makes me happy is learning. Okay? Yes, sir, my brother.
So for the second step, multiply 2 times 3.
You got to multiply the x as well. Because it's 2 times the first term times the second term, my brother. So 2 times 3 times x is 6x in this case. Does that make sense? Thank you for your honesty, kid. Now again, I don't want to learn it. Fine, don't. You're going to suffer later, though. I promise you. It's going to take a lot longer. So I suggest just focus and learn it. But let's practice a couple. Let's practice. X plus 1 squared. First term squared, x squared. There's a plus here, so plus 2 times the first times the second, 2x, plus the second term squared. Done. Done. Come on, be honest. That's a lot better than doing it the long way. B, first term squared. 4m squared. Now, Good job, my brother. You got this. You got this. 2 times the first times the second. And there's a minus here, though. So there's minus 2 times the first times the second. 20m, guys. 2 times the first times the second. 2 times 2 is 4 times 5 is 20. Plus the second term squared, 25. First term squared, and squared. Minus 2 times the first times the second. 8n. Exactly. Plus the second term squared. Excellent. Last but not least, first term squared. 9x squared. Plus, because there's a plus here, 2 times the first times the second. 2 times the first times the second. 48x. Plus, second term squared is 64. Yes, sir.
Does it make a difference if you multiply the two inner ones first and then multiply with?
It doesn't matter if you multiply these two inner ones first or not. 3 times 8 times 2 is the same thing. Remember we learned the commutative property months ago? That's why we learned the commutative property for things like this. The order of multiplication doesn't matter. Please don't pack up. We're not done. Okay? And last but not least, difference of squares. A difference of squares, this occurs when you multiply the sum of two terms times the difference of the exact same terms. The product will equal the square of the first term minus the square of the second term. Again, you don't want to memorize it? Don't. This is what you will have to do if you do it the long way. First term times first term, so that's a squared minus ab plus ab minus b squared. These two middle terms cancel, and you got a squared minus b squared. You could do that if you so choose. Or you could do the square of the first term, literally, minus the square of the second term, and you are literally done. So in this example, you got x minus 5 times x plus 5. Are they both the exact same numbers, the only difference being a negative and a positive? So take the first term, which is x, and square it. Take the second term, which is 5, square it, and subtract the 2, and you're done. Or you could do it the long way. Your choice. But I promise you, learning it now will benefit you later. You can go to lunch. I will finish the video. God bless you all. Check the calendar. Have a great day. Give me 1 second. Okay, so real quick. X minus 3 times x plus 3. First term squared minus second term squared. Done. X plus 6 times x minus 6. First term squared minus second term squared. Done. 4x plus 3y times 4x minus 3y. First term squared minus second term squared. Done. Last but not least, x plus 6y times x minus 6y. First term squared minus second term squared. And you are done. Gentlemen, I hope you learned a lot. Have a wonderful day. Thanks again, and I'll talk to you later. Have a great day. Bye-bye.